There we go. All right. So we're going to keep working with finding the 6 trig functions of an angle. And this is kind of an overcomplicated way of saying this. So we're still looking at kind of our starting position, usually being our origin. And we need to try and kind of figure out where this is going to be. We know the terminal side of our angle is going to be parallel to x plus y equals 3. Our initial side is here, but we need to try and figure out where our terminal side is. When we are in standard position, which is going to be where we are pretty much every time, that just means it goes through our origin. It goes through 0, 0. So what we need to know from this thing, this line, is we need to know the slope. So our first step is going to be to find that slope. So our first step is to find the slope of that x plus y equals 3. That's meant to be a 3. There we go. How do I find the slope of x plus y equals 3? Subtract x. That's going to give me y equals minus x plus 3, or 3 minus x. So what's our slope? -1. So if we think about the line that has a slope of -1 and goes through the origin, so it's going to start here, and it's a quadrant. So we have a slope of -1. Usually that means we go down 1, right 1, down 1, right 1, or up 1, left 1, up 1, left 1. So this is the line we're looking at here. Ooh, I'm so good at lines. And we're looking in quadrant 2. Which one's quadrant 2? The top left. This guy up here. So what we want to know is, what's an ordered pair of a point that's on this line? It's like you can use either one of them. You could use -1 and 1. I could use -2, 2. I'm going to use -1, 1 just because it's a little easier. But because we went up 1, our y is +1. Our x is -1. So we can use the point -1, 1. So when we're doing this, it's really just trying to find a point on here that matches. From this, we're going to use what we did yesterday to find our sine and cosine. Because what we have is that we're looking at that teeny tiny angle there. I know my rise over here was 1. This was -1. So my adjacent side, my cosine, my opposite side is a +1. And we need to find our hypotenuse, that r. How do I find my r again? Yep. Of our x squared minus 1 and 1. You're right. I was going to say Pythagorean theorem, a squared plus b squared equals c squared. Totally fine. A squared, b squared, c squared. This is just doing it all in one step. So our r is what?
Teacher, sorry for this late announcement. It's time for the 3rd period Rita testers to head to their testing room. Thank you.
Say it again because I couldn't hear you because she's loud. Yep, square root of 2. So the triangle we're thinking about for this, just I'm going to draw it a little bit bigger because that graph is very small. Looks like this. Our right angle's over here. Our angle that's at the origin, that's this point right here, where we have a -1, +1, and our square root of 2. Okay. Well, we're gonna do our sine, cosine, tangent stuff. Yeah, that's what the trig functions, that's what those are. We gotta find the trig function values.
I have a question. Why
Yes, dear.
did we start at y equals 3 with the slope? Like in the beginning. What was that?
Say it again.
Why did we start at 0 and not at negative at 3?
Because it's not that it's going through, it's not using the line of this. It's parallel to the line.
Oh,
Okay, so it's gonna have the same slope. So we know that this side over here is parallel to this line. So this line is actually up here. But it's gonna be parallel to it. So all we care about is the slope. Because I think there's one on the homework that asks you to do a parallel like that. 90% sure. Oh, that's right, but my homework 3 didn't print. So let's do our trig functions. Looking at our little triangle here, we've got our sine of our angle here, whatever angle we want to call it. If you want to call it theta, if you want to call it alpha, beta, x, whatever you want to call it. I'm going to call it alpha just because I can. Let's go here. What's our sine going to be? 1 over square root of 2, which is really going to be square root of 2 over 2. We got to rationalize it. No square roots in denominators. So our cosine is going to be? Negative. Or 1 over, or yeah, negative 1 over square root of 2. So we have our minus square root of 2 over 2. What's up? We're looking at this angle here. Opposite is over here. Adjacent over here. Cool. And then our tangent is going to be what? Sorry, I'm just moving these things up real quick and I'll write it, I promise. I just need a little bit of space. We're going to have our, whoa, wrong pen. Our tangent of that angle is negative 1. Okay, questions on those 3? Because we use those 3 to get our other 3. Sine goes with which one? Cosecant, CSC. Each pair only gets one co. So sine goes with the co, which is going to be what? Square root of 2. If we use cosecant with sine, secant goes with cosine. What's secant going to be? Negative square root of 2. And our cotangent? Negative 1. Okay, so it's doing the same kind of thing. It's just that we have to find our own point using the slope. So it's the same thing that we kind of ended on yesterday. Questions on this one? Okay, so we have a couple other kinds of problems that we see in homework C. So the next one we're going to do, we've got 2 over here. We are, again, finding all 6 trig values. When it says find the trig functions, or find the values of the trig functions, that means all 6. So find the values of the trig functions means we're doing all 6 when we know this. So, and these are 2 separate problems here, just to make that very clear. This is 2 separate problems. So the first one we're looking at is tangent of theta is negative 3/4, and that sine is positive. So the first thing we need to know is what quadrant are we in? Let's see. Because sine is positive, that means my y's are positive, right? But tangent's negative, so are my cosines going to be positive or negative? Cosines have to be negative. So that's going to be in quadrant 2. Okay, because cosines are my x's, sines are my y's.
Wait, how does that work?
Since my cosine is negative, sine over cosine, positive over a negative is going to be negative. Okay, so what that helps us do is that helps us kind of figure out which direction my triangle needs to face. And it lets us know which pieces are going to be negative. So quadrant 2, we're going to shape it like this. The reason I do that is because if I was to put this on my coordinate plane, it would be shaped like that. It puts me in quadrant 2. Okay? Because we're always looking at our angle that goes to the origin. So this is going to be our guy. So what pieces of our triangle do we know? What's up?
So the angle that faces the angle that we got from the origin is the opposite.
The side opposite the angle is the opposite, yes. So it's always going, it's the side that does not touch the angle is your opposite. Because the angle will touch the adjacent and it will touch the hypotenuse. Whichever one it does not touch, that's our opposite. So which pieces of our triangle do we know the measurements for? We know our opposite's going to be what? Three. Two, opposite over adjacent. So our opposite's going to be 3. Our adjacent's going to be -4. Good. Because we're in quadrant 2, that means our x's are negative. So we have to figure out which piece gets the negative. That's why we looked at our quadrant first, so we knew which side had our negative on it. My x's are negative in quadrant 2, so my adjacent side gets the negative. So what is our hypotenuse going to be? 5. This is a 3, 4, 5 triangle. You can absolutely use Pythagorean theorem to get there, but we also can see that it's a 3, 4, 5. So we're going to fill in our trig functions, same way we've been doing for the others. So our sine of this angle, which they've named theta, so I'm going to use theta, is going to be what? 3/5. Cosine, -4/5. Tangent, careful, 3/4, -3/4. And then since that's the one that they gave us, we can spot check up here that we've got that. That's our opposite over adjacent, 3/4. What is our cosecant? 5/3, 5/3. It's the reciprocal of our sine. So our secant, -5/4. And our cotangent, -4/3. Okay. Not too bad, not too bad. I can do this. Questions on that one? Okay. So then we're going to do the same thing over here, but we're given some different information. I've got that my cosine is -1/3, and my sine is less than 0. We're in quadrant 3. Because sine and cosine are both going to be negative. So that means when I'm going to draw my triangle, I'm going to draw it so that it looks like it's in quadrant 3, because that really helps me get everything kind of set up the way we want. We know we want it down on quadrant 3. So it's going to be this guy, this guy, this guy. And that is the tiniest of triangles. Oh my gosh, I'm going to draw that bigger. Something like that. And this is the angle we're looking at here. It's always the angle that's against the origin. So what pieces do we know here? So our adjacent side is going to have what unit? I was going to say, Yeah, it's gonna have our 1, right? Because adjacent over hypotenuse. So our hypotenuse is gonna have that 3. Which piece is gonna be minus?
Oh, no, the 1.
The 1. Because my x's are negative. And my y's are negative. We're in quadrant 3 here. I didn't write that down. Quadrant 3. So I know this side's negative 1. I know my hypotenuse is 3. How do I figure out this side? Pythagorean theorem. We're going to take our negative 1 squared plus whatever that other side is squared, and it should equal 3 squared. So we'll have our 1 plus our b squared is 9. So our b squared is 8, which means b is, say it again? 2 square root of 2. Square root of 8 will simplify down to be 2 square root of 2. So this side here are 2 square root of 2. Is this positive or is this negative?
Negative.
Negative. We're in quadrant 3. Our sines and our cosines, our x's and our y's are negative. So then we're ready to set up our trig functions. This feels like it's going to be one of the simple parts, the building of the triangle, and that we need to focus on our trig functions. It's really the opposite way. Build the triangle and take your time there. Once we get to the trig functions, it's a plug and chug situation. This is where we need to slow down and spend our time. Because if the triangle's wrong, we have no chance over here. So what do we get for our sine of this angle? Get our negative 2 square root of 2 over 3. How about for cosine? Negative 1 over 3. Tangent. Because we get our negative 2 square root of 2 over negative 1, right? Opposite over adjacent. That negative over a negative, we get just our 2 square root of 2. Our other 3. So our sine goes with our cosecant. What's our cosecant going to be?
3 root 2 over
Yes, I'm going to go through it though. So first thing I'm going to do, I'm going to take the reciprocal. So we have our 3 over our negative 2 square root of 2. But we don't want radicals in our denominator. So we're multiplying by our square root of 2 over square root of 2. That's going to give us that negative 3 square root of 2. And this is going to give us 2 times 2. That's where we're getting that 4 from. So it's going to look like that. So it's kind of messy. I'm just going to put a little line right here just so we can tell the 2 pieces apart. There we go. Okay, just so it's a little bit easier to read those 2 pieces. So then let's do our secant. That one's a little bit less messy.
3 over
Yeah, 3 over negative 1,
negative.
which is the same thing as negative 3. And then our cotangent. When in doubt, write it out even with it bad first. So we'll have our negative 1 over negative 2 square root of 2. So I'm going to put our negatives already canceling out. 1 over 2 square root of 2. Then we would multiply by square root of 2 over square root of 2 to get square root of 2 over 4. I was going to say, when in doubt, if you're struggling to do it mentally, write it down. Okay, as long as we can write it, we're good. Okay, we have one other kind of problem we see in 6-2C. And I just think it's going to be one of those we just overthink it. And it's when we give you an angle. These are the last two on 6C, 6-2C. Because there's, like I said, way too many things in this one section. Holy cow. So we're finding the exact values of the trig functions for each angle. So if we think about angle 180. Where is angle 180? Yeah, it's on the other side. So if this is normally where we start, we're looking over here, right? That's 180. What ordered pair is that? I just say slow down, y'all. -1, 0. Right? Well, when we're looking at these ordered pairs, remember what we said? This guy, cosine, and this guy is sine. So sine of 180 degrees is what? 0. Cosine of 180 degrees is -1. How could I find tangent though? I don't really have like a hypotenuse going on here. Sine over cosine. Tangent of 180. We do our sine over cosine. 0 over -1, that's 0. 0 divided by anything is 0. So our, oh, I did not give myself enough space here. Hang on a second. I gotta move those up just a smidge. Boop, there we go. So our cosecant of 180, what's the reciprocal of 0? Remember, 0 is a whole number, 0 over 1. 1 over 0. 1 over 0 is what? Undefined. We cannot divide by 0. That's I have one cookie to split among my no friends. Aw. Undefined. So our secant of 180 is -1. This is, again, -1 over 1. When we take the reciprocal, we get 1 over -1, which is the same thing as -1. And then our last one here is our cotangent of 180 degrees. Undefined. Reciprocal of this thing, 0 over -1, becomes -1 over 0. Whole numbers always have an invisible over 1. Undefined. So think about 0. With the zeros, think about it if I had 2 and I was trying to write that as a fraction, we'd write it as 2 over 1, right? Same thing with 0. 0 is the same thing as 0 over 1. It's a whole number. So we have to take the reciprocal of that. Our -1, it's the same thing. It's -1 over 1. When I take the reciprocal, it just simplifies down to be -1 again. Okay? So, as I say, the ones with the angles, we tend to just overthink. So those are all of them. And those undefineds are what they mean when they say when possible. is we might have some that are undefined. So let's do the same thing for our 5 pi over 2. What that means is I need to figure out where the heck that is on our... You can change it to degrees if you want to. Or we could go, how many... What do we get if I go all the way around the circle? How many radians is that? That's our 2 pi, right? If I go all the way around. This is, yeah, this is 4 pi over 2, which would be 2 pi plus a pi over 2, 1 pi over 2. Where's pi over 2? Wait, where is it? At the top. Because remember, this is pi over here. So if I want to go from 0 pi, 2 pi, pi over 2. Or if I'm counting by pi over 2, so I'd have pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So it's this point up here. What is a point that's on this angle that we could work with? 0, positive 1. And again, my x's are my cosines, my y's are my sines. So my sine of 5 pi over 2 is what? 1. My cosine of 5 pi over 2 is 0. So my tangent of 5 pi over 2 is 0. When in doubt, build it. Tangent is made of sine over cosine, because we don't really have like a triangle here. I was gonna say you could build out a triangle here if you really want to. We've got one. We could do it, except that it's a 90-degree angle. That's our center angle, and it's not really something we can do. So our sine over cosine is going to be the way to go. So 1 over 0, which is undefined. You could put UNDF if you really want to, if you really don't want to write it out. I'll do that sometimes. And so you look on answer keys, you'll see it. I'll write it as just So our cosecant of 5 pi over 2 is going to be what?
1.
Our secant of 5 pi over 2. Careful. Undefined. Whenever we have a 0 as our answer, remember that's whole number of 0 over 1. So our reciprocal is 1 over 0, which is undefined. So our cotangent, last one on this guy, 5 pi over 2. What's our cotangent going to be? 0 over 1. It's this guy. We take the reciprocal here, 0 over 1. That's the same thing as 0. Okay? So they're kind of icky, kind of unpleasant. Entirely possible. I make no guarantees ever. Okay? So before we kind of wrap up for the day, I want to go through some unit circle tips. Because I told you I'd show you guys a few techniques, some things we can do to help us remember pieces of the unit circle. So I'm going to show you several things here. I'm going to give you guys blank unit circles if you like. You don't have to use them, but I'm going to pass them out so you have them. Just because I'm going to go through a lot of things here. There's not really tricks for the degrees. I kind of hope that you guys know how to do degrees. But like we'll kind of bump into them on several things on here. then if you ever want extras of the unit circles, I keep them up in that pocket and I will continue to refill them over and over and over again. And I know there's a whole lot of stuff written on the side that feels like gibberish. I'm gonna talk to you all over. Because honestly, I was kind of writing them there so that I remembered which techniques I was gonna show you. So our degrees, we tend to do, like we're gonna start with our 0 and our 90 and our 180. We're usually quite comfortable with those. And for our quadrant 1, there is a little way that you can work on to help remember that's gonna come up on something else, and it's using your hand. So if you have your hand be quadrant 1, this guy's 0, this guy's 90, 30, 45, 60. We're going to use it in a later thing too, but that's a piece here. So we got our 30, 45, 60 degrees. So we're going to have our 30, 45, 60 on our degrees. So when you're coming through to fill in your degrees, you can either do it like additive wise, you can do this in your own way. You can take our 90 plus our 30 to get here. The way that I tend to do it, my instinct on it is I tend to do that in clusters where I will do my 45s in one thought process and I'll fill these in. So I'll do the 90 plus 45 to get me to my 135, 180 plus 45 to get me to my 225. I'm just making sure I'm double checking stuff because I want to make sure I don't give you guys wrong numbers. We've got our 270 down here because we're adding another 45. And then we add a 45 to get to 315. And this would be 360 on our degrees. You don't have to write both 0 and 360. I do not care which one you pick. This image for me has 2 blanks. I know for you guys it doesn't. It's because I grabbed one off of Google that was of a higher clarity line. So I tend to do my 30s and 60s at the same time because we can just kind of plug and chug with our 30s. What's up?
If you start at 0, doesn't it just go like 30, 15, 15, 30, 30, 15, 15?
Yep, 30, absolutely. 30, 15, 15, 30. 30, 15, 15, 30. That is absolutely valid strategy through it as well. There are so many different ways and so many different orders you can go in to fill it in. And I don't care what order you do. I do not care. I am not going to watch and say, what'd you do first? I don't care. Do whichever works for your brain. So the way that I do my degrees, I tend to do my 45s because in my brain it feels like a separate thought process than the 30s. But if the 30, 15, 15, 30 works for you, great. I love it. So, but I can do 30, 60, 90, plus 30 gives me 120, plus 30 gives me 150, plus 30 gives me 180, plus 30, we're at 210. Oops, if I draw 2. Then we're at 240. We're back at 270, 300, and 330. So there's not really tons of tricks for our degrees. I mean, there's a couple, but it's not tons. We just kind of have to get through them and get through them quickly. For our radians, what this little thing I have over here is talking about our denominators. So the denominator at the top is going to be 2. It's going to match as it goes outwards, and it counts up. So we're going to have 2, 3, 4, and 6. We didn't use fifths at all in the unit circle. And then we're going to have 2. Oh, we had 2 at the top, so then we have 3, 4, and 6. At the bottom, it goes the other direction. So we have 2 at the bottom, 3, 4, 6, and 3, 4, 6. Because honestly, getting those denominators in the right spot is one of the hardest parts. For quadrant 1, our radian numerators are all pi. Oh, this guy's 0. I forgot that guy. So we're going to have pi over 6, pi over 4, pi over 3, pi over 2. For quadrant 2, it's going to be your denominator minus 1. So 3 minus 1 is 2 pi. 4 minus 1 is 3 pi. 6 minus 1 is 5 pi. Our 180 is the same thing as pi. I just kind of missed that one. For quadrant 3, add 1. 6 plus 1, 7 pi. 4 plus 1, 5 pi. 3 plus 1, 4 pi. 2 plus 1, 3 pi. And then quadrant 4 is, if you think with our common denominator, whatever our 2 pi would be, minus 1. So with a denominator of 6, 2 pi would be 12. So if we take away 1, we're at 11. 11 pi over 6. 4 would make it 8 pi over 4. That would give me 2 pi. So 8 minus 1 gives us 7 pi. 6 minus 1 would give us 5 pi. There are many, many different ways of remembering that. You can also do it as all our ones. Then we have 2, 3, 5, 7, 5, 4, 5, 7, 11. I've seen it as plus or minus plus prime. I've seen that, where these are all prime numbers, and there's lots of different ways of remembering it. This is just the one that works best for me, so it's the one that I tend to pull up in my brain. I have put a link on the Canvas page that takes you to, I think it's a WikiHow of memorizing the unit circle, and I believe it has 15 different tricks. Also on YouTube, there's a gabillion different options. The last one I'm going to show you is our for our coordinate planes.
I have a question.
Yes, dear.
How is 5 pi over 2 down there, but when we did
That's
it
what I said.
on the angle, it was on the top? Yeah.
5 pi over 2. That's a 3. That was a 3.
Oh.
Sorry, that's my bad handwriting. All right, so our last piece that we're going to talk about is our ordered pairs, because that's sometimes the really tricky thing to remember. Our 90s are easiest to remember because we're going to have our 1, 0, our 0, 1, negative 1, 0, and our, oh, my ordered pairs off, oh, no, it's not. And our negative 1, or 0, negative 1. Goodness. And then if we use that same hand that we did that I showed you for our 30, 60, 90, we can do cosine with this. Remember, cosines are our x's. So on our pi over 6, if I'm looking at this guy, I have 3 over 1. So what this is going to be, our cosine has our square root of 3 first and our 1. Both of them are over 2's. If I look at my pi over 4, I have 2 and 2. So we're going to have our square root of 2, square root of 2. Always over 2. Pi over 3, that's this guy. 1, 3. 1 square root of 3. All are over 2. That's a 3. I know it's trash handwriting. Okay? 1, 3. So you can use this to help you get quadrant 1. From here, it's all about reflections. The difference between this one and this one is that my x is now negative. So it's going to match up. We're going to have our minus 1/2 here. Positive square root of 3 over 2. And in fact, what I tend to do from there is I'll come and hit that one in all of its matching pieces, because that guy is going to match up with this one, match up with this one, match up with this one. It's just different signs. Same numbers, different signs. So we'll have our negative 1/2 negative square root of 3 over 2. Our positive 1/2 negative square root of 3 over 2. Okay, so you can use that to kind of fill in all of our ordered pairs there. And then these guys will match up, so you can do it just changing signs here. And these guys match up, so you can do it changing signs there. And I'm sorry, we did not actually have time to ask questions on 62C today, but I wanted to take some time to go through this because we're gonna have our free unit circle quiz next week. Not Tuesday. Tuesday, we have our first quiz. So I'm gonna put it up here, people pick on your way out. Review for quiz number 1, I'm gonna put it on a little gray table right here. Just because I wanna make sure you guys get it. I'm just fluffing them out a little so they're easy to pick up. Have a great long weekend. I'll see you Tuesday. Don't see you Monday. We're at the weekend. Okay, so grab the review on your way out. Have a great weekend. Email me or Canvas message or transfer your questions.
See you in the drawer.
Talking about it today, but and then we got the now. It's not that we're putting it to something. Writing it. It's not that we're not preparing. We're writing it using. So we know cosine. We did that with with this one, right? This is using only signs. We know that this is 1 over cosine. I can replace the cosine with it. There it is. I saw that one click in. Yeah, you too.
Something that you're, that was meant to be a negative, right? We're just going to next time.
Yeah. And handwriting is not going to play a humongo part. I'm usually really good at ciphering and speed writing, even yours. Yours is honestly not the worst handwriting we've got. And I guarantee you, I do the worst handwriting in the class. Guaranteed.
You got some money on this part.
To be fair, you're not doing a speed test with math.
Oh, no, that's your test?
Uh-huh. Next week. What's up? And, 4-3, yes.
I'm just